All right. Welcome, guys, to today's Arduino workshop. Today's number 10th, yes. Okay. I'm your host, Yash Karwal. I'm also the president of Hyperloop. So today we're going over basically the introductions to Arduino, what it is, and like how to program your own and simulating your own few circuits at the end of today's lecture. All right. So I already asked you guys about, who has experience with Arduino. So since most of you guys are probably new, so let's ask about like, what is an Arduino, right? I remember seeing a question on the actual forums about whether you can do you can basically do computer tasks with an Arduino. And the answer is an Arduino is basically a microcontroller, not exactly a computer, but it can do stuff with sensors and like any external hardware controls. So it's also open source. So there's many different brands out there that can actually manufacture the same board with the same parts. So you can have a variety of different types of quality in terms of and different price points of the same exact board. It's also in the language of C. So those who are experienced in the language of C, are there anyone who knows how to program in C here?
I do.
Nice. But yeah, so this is pretty bit more easier for you then. It's okay, you just need to know like the basics of like this programming in general, but like yeah, some C stuff as well. It's kind of nice. But it's also pretty easy to start like learning how to do circuitry and programming together and controlling your own small little things. So let's start off with inspiring you with some projects of ours. So here at Speed Hyperloop, one of our big things is actually the pod itself. If you look closely right here is actually a small Arduino. It's called the micro, and it controls the functionality of the entire pod. It's sensors. Its ability to basically be controlled with the remote that's down here, which is also a custom remote that we created using an Arduino as well. So that's our Nano. I can see, yeah, it's Arduino Nano right there, and a micro on that one. And they use this wireless receiver right there to communicate between the pod and the controller. Another project that we have here is actually the line following cars. Those who have participated in the last semester's Arduino workshop, you guys have worked with these cars and programming these and around the track and everything else. I also have some of my own projects I want to show you guys. Just a little bit of like a way of like introducing the project, different things you can do with an Arduino. So start off with like the basics of just doing small button controls with LED lights. Then you can have something like this, where you click a button and it turns an LED, like a light on or LED on, and different states of it. So this project here is just like a test for the circuitry of what became this right here. So going through different modes, making it fade in, fade out even. So this is 3D printed lamp as well, making this one of, one small little Arduino it has like 11 different modes on it too. And then you can see kind of fade away between two different colors, from purple to like a yellow with the blue on the bottom as well. You can see it happen like that. That's one of them. And then if you go like learn a little bit more, you can do something with actually with this, which is if those who were here for a very first soldering workshop, we made a macro board for a game for Sound Voltex. And this was a prototype board for that one, where we use an Arduino micro to give keyboard commands using buttons into the computer. And now we can play our own games with it too. And from there, you can go step it up a little bit more and learn some program. If you know some programming with Java, you can do something with Arduino, with Android Studio and the Bluetooth module with an Arduino, where if you press the buttons, it'll move these servo motors left and right. So you can create your own little robot that's controlled using Bluetooth instead. And then a few more a bunch, so I'll just go through all of them as well. Something else is here is for a stepper motor control as well. So a stepper motor here, it is being controlled with the angles. So each time I press a button, it'll go about 60 degrees rotation, which was used in this right here to actually propel balls from, I think it was like 4 or 5 meters away using air. So each time I press the button, it would rotate 60 degrees and to shoot the next ball through the machine. And then also have RGB lights as well that need to be controlled. And those who have seen our Blinky Learner 3 kits from last semester, this is a prototype board that also, again, controlled with Arduino, and also a computer program that I wrote to extract audio, so that the audio signal from the computer will go into the Arduino and then run this like LED chaser circuit. And this whole thing ends up being for actually a table that I created here that actually I'm sitting on right now. But this is all controlled with an Arduino. So a lot of things you can do with it's right there, and that's a small little circuit over there. And the whole thing's synced to audio and everything. So it's a lot you can do with Arduino. It really just depends on your imagination, as they all say. Imagination is really your limit, as well as certain limits that you do know that the Arduino is capable of or it isn't capable of. So let's talk about the usual Arduino that people see, which is the Arduino Uno. So it looks like this. It is a pretty, I'd say, size of a palm, and it has many different pins on there. There are 14 digital pins on this side, right here. So what that means is that these pins can only output ones and zeros. So that's digital, right? So it's either off or on, high or low, or low or high, off or on, 0 and 1. So, and usually you use pins 2 through 13. You don't use 0 and 1 because they're communication pins for the actual Arduino. Unless you're using, let's say, a communication module like a Bluetooth or something else that does use TX, which is transfer communicating, and then RX for receiving data. Otherwise, don't really want to use these two. Use 2 through 13. And then these right here, you see 11, 10, 9, 6, 5, 3. They all have a little accent or swinging line on top of it next to them. That means that they are PWM, which stands for pulse width modulation. We'll talk about that in the next slide. But for now, just know that there are certain pins with this mark, and it's for a reason that we'll talk about in a bit. On the left side, we have our 6 analog pins. So these pins here can actually read analog signals. So that's not just zeros and ones, but rather like numbers between 0 through 1023. You can basically do is if you put say a voltage through that's like 3.3 volts. I think it's at the halfway point of 5. I'm not gonna do that right now, but yeah, 2.5. Yeah, so 2.5 volts through it, then it will read the half of 1023. So its range is 0 to 1023, but it can read more than just zeros and ones. So you can put different values to it. What analog really means is a continuous signal rather than just a 0 or a 1. It's a kind of like a sine wave of sorts. Yeah, you can also use these analog pins as digital pins as well. So you can output, or we can also read digital signals, but they're mainly used, their main task is to read analog signals. So yeah. We can also talk about some power stuff here too. We have our main V-in or voltage in source through the main power or the USB. This can go from 5 to 12 volts, which is the unit for how much force the electricity comes from. do we know what voltage is, current is? Well, not the actual definition per se, but rather the idea of voltage, current, resistance, Ohm's law, or I'll just go through it real quick. Or okay. So for those who don't know, though, voltage is basically the force of the electricity. Current is the actual, if you think of like a water, like a pipe in a water in a pipe, I would say current is the actual water molecules themselves. So like how many particles are in there. Voltage is the force or the pressure that the water flows through. And then resistance is just like, that's restricting the flow, or like it's going against the flow. So we want to also just make sure that our voltage input doesn't go over 12 volts. And I'll talk about that in a bit. But yeah, let's just have our grounds, which are negative. So for positive is 5 volts, negative is grounds. It's a 3.3 volt line as well for those electronics that require a bit less voltage. SDSCL are all communication protocols for I2C. We're not going to talk about that much in today, but if you do want to know more, you can always ask us. Yeah. All right. So PWM, or pulse width modulation, is basically a trick to kind of emulate an analog output with a digital signal. So since a digital signal is either low or high, or 0 or 1, or 0 volts or 5 volts, let's say you want an LED to be not fully bright, but like kind of bright, depending on something, right? So you use the PWM signal to basically turn that LED off and on at a really at a different rate, or you see like different time, and it's a different frequency, so that it will kind of look like as if it's dim when it's actually turning on and off at full brightness, just really fast. If you look here, the duty cycle is noted right here, or it is the how much percentage of time is the component on over the total period of time that it's running. So let's say if you look at the period right here, it's from say this peak here to here. That's its period. It's only on 10% of the time, that's off the rest of it. So you're getting a 10% duty cycle, which is like 10% of its overall voltage. So that's basically one way of tricking our eyes to see different voltage levels as well as electronics. So you can use a digital signal as an analog signal, but it's only for certain pins on the Arduino. All right, so Ohm's law again. So SSV equals IR, or voltage equals current times resistance. Just always make sure that you know what kind of voltages, what kind of currents you're using, what kind of resistance you have. One thing I ran into actually last night was I overheated an LED strip, or it was very light, because it was drawing way too much current. And since the wires were so thin, they overheated and could almost cause a fire. So always make sure that you know and you match the power requirements. So power is equal to current times voltage as well. So in case if you look at different specs for different things, you can make sure that you're getting the right power specifications. And so right here, and these two are in series and these two are in parallel. So current does not change over components in series. So these two resistors have the same current, but the voltages could differ. So you can use V equals IR to find out. I say different resistance here versus here. And you have the same current that's flowing from the battery to find out the voltages in this versus this. And then in parallel circuits, the current changes, but the voltage doesn't. So you can figure out what currents these two have based on the voltage that you found from here. So it's like a little bit of circuit analysis. We'll do this more in the circuit construction workshop that was supposed to be scheduled before this workshop, but since it was pushed back, we'll go more in depth in that one. Yeah. So programming wise, We have two, if you look at, if you open up a new sketch or in Arduino, the IDE, if you open it up, you'll usually come up with two functions. You have the setup and loop. I can show you right now. Say if I were to open up a new sketch or a new code document, you'll see that there's only two things, setup and loop. So setup is basically, it'll run the code once to kind of set up your controller to its current, to whatever tasks you wanted to do. So you have stuff like, if you want to set up commands for, let's say in this code right here, just to get up all the pins lined up to like their proper modes, and say a setup condition of like, I want this light to be on when it first turns on. So it'll do that. So this code is just to set up the Arduino into whatever it needs to do. Then the loop function is your main body. It will continuously loop the loop function. So you always, if you want to pull for data from the pins, if you want to do some calculations, some other, tasks with the Arduino, they all go in the loop. So that's your main body, it's your main code. You also create your own functions as well, but make sure you call them in the loop, because the loop will be what it'll be running the entire time. So for variable definitions, most of the time you'll define variables with a syntax of, let's say, the data type, then its name is equal to a value. So you have stuff like integers, doubles, which is basically decimals, booleans, which is basically true or false, so like zeros or ones. String is a text string, and char or just character. So if you want to do most variables, we define in this way, just so that you know what data type you're using, and it's just a more common way in most languages in general, like Java and C++. It's also, you can also use const or const, which is basically to name a constant. So if you want to define, let's say, one value, say a time, right? So say this time right here, it's going to be used multiple times in my code later on, but it's going to be a constant because like I want to keep this time a certain value, but I don't want to keep changing every single instance of this value. Just have a variable named time instead, so I can just change it on top in the actual definition, and it'll change everywhere else that time is referred to. That's why you use constant. So variables are basically data that will change throughout, and then constants are variables that are not going to be varying. Now let's use hashtag define. This right here is a more common way to define pins, just so you know you have a difference in normal variable names and versus the pins names. So you can easily refer to all your pins, what each pin is labeled as, and then your actual definitions of normal variables that you're using in the code, so you don't get them too confused and cause some problem in your code. You use comments, 2 backslashes, or forward slashes, I don't know. I never knew the definition of, but 2 slashes to make line comments, which are these right here. So it'll like a single line comment, it'll comment out whatever's after it. So you can write normal things and it won't be read by the actual compiler or the Arduino. You can use the slash with the asterisk and an asterisk slash at the end, right up here, to make a block comment, which is basically just using multiple lines of code just for comments. So you can use that just to say, put information about what your code does. You can do when your code was first made and other information that you need to put in your code. I suggest you guys to make sure you comment your code to make sure you know what you're doing, so that next time you come back to it, you know how it is. I've had multiple instances where I would program something for like 3-4 hours, and then I come back to it after a week or two, and I'm like, I can't read my code, or I have to really read the code to understand what's happening, because I do not know what happened. So commenting your code makes your life easier. It's a little bit extra, but it's just you just do it. also help people read your code later on if you need to share your code with other people to collaborate on a project. Right. So let's talk about the actual functions that we're going to be using a lot of. The first one being pin mode. So pin mode goes onto usually in your setup function. So right here, and you can see that it basically defines what each pin is going to be doing. Is it an output or is it input? Or is it an input pull up? So these two are just like to set, what will happen is normal input will usually it'll read a 0 by default unless you put in a 5-volt signal into the pin. Input pull up will read a 1 unless you put a ground or a 0 into the pin. So sometimes you want to use pull up versus normal input. This depends on your use case. And then output is just to change your pin to output so that you can output zeros and ones. Or yeah, input is also used for analog pins. So we want to read analog signals. Make sure you set that pin as an input. But yeah. So the digital write and analog write functions. So the digital write is to write zeros and ones from the pins to an output. Let's say to an LED. You want to turn the LED on, you can write digital write and then put that LED in its pin and it's such a high. And it'll output a 5 volts into the whatever it is you want to put it to. One thing to note when you do hook things up though, these pins are rated for about 40 milliamps of current. So don't put, let's say one LED is fine on one pin, but don't put 3 LEDs because one LED takes 20 milliamps current to run. So 3 of them will take 60, which is more than what the pin can supply. And that could cause a problem or a fire, depending on how much current you're drawing, or just the whole thing turning off. And then the actual V-in of the Arduino that we've seen before. Let's go back real quick. All right, so the V-in being this one right here, it can support to 800 milliamps of current. So you can do a little bit more with this one, but again, be careful. I've driven a motor that it takes out 4 amps to the V-in pin when I was first experimenting with stuff, and the Arduino got pretty hot, and it was starting to smoke. So again, power requirements are a must. Make sure you know what kind of power you're using, how much you're drawing. Okay. So the analog write, you can use for the PWM pins only. And those ones, again, it goes from a range of 0 to 255. So so you can make a LED turn half brightness at 127 if you put up with that. Yeah. So the actual syntax for both of these is basically just putting your pin and then putting how much. So putting high and low for digital write is basically zeros and ones. For analog write, just put a number from 0 to 85 on the side. And then the reading pins, reading functions, digital read and analog read. These two are for reading from the pins. So if you set your pins to input, then you can put these, you basically put your variable name or your pin name in the function here. Yes, James?
When you get a chance, could you explain a little bit about like the pull-up
yeah.
concept? Yeah.
I'll go back right after this one. Yeah.
Sounds good.
So, but yeah, so you're gonna read your what was that? Sorry. So you put your variable here or your pin here, and it'll read that one. Digital read will go 0 as ones. Analog read from your analog pins can read 0 to 1023. To answer your question about input pull-up, so input normally has a default value of 0. So what will happen is if you want to basically do is when you read, say a value, you want to put a 5-volt signal or a 1 according in the digital space, right? A 1 into the Arduino, and then it'll read it as a 1. Input pull-up puts a default state as a 1 or a high or 5 volts. So then you basically want to ground that pin or set to 0 to put it down to 0. For certain scenarios, you want to use pull-up over normal input. Let's say for switches and buttons, I use input pull-up more often, just so I set the 5-volt. Sorry, I set that pin to ground instead of putting in a 5-volt. But certain things like a Hall sensor, a magnetic Hall sensor, so it detects whether there's a presence of a magnet or not. Those sensors actually output a low instead of a high. So they actually output 0 volts when there's a magnet around them. So that's when you're going to use input pull-up. That way you'll kind of invert the logic so that when the Hall sensor detects a magnet, then that pin can read that 0 happened versus not knowing. Because if you put using input normal, since the default state is 0 already, if you put a 0 in the input, nothing will change, right? That's why it's there for like those kind of circumstances. Does that help answer your question?
Yeah, so it's just basically it's just able to read it's able to read when a signal is 0.
Yeah, basically, yeah.
Okay,
So versus and normal input will read it when the signal is high or a 1 or 5 volts.
understood. Thanks.
No problem. All right. Another function that I use quite often is map, and it basically maps a variable that you have a value from one scale to another. So in this example right here in LED val, I was reading this potentiometer, so it scales from 0 to 1023, and I want to map it to the LED's brightness. So the analog right that I want to put that scales from 0 to 255. So I mapped the potentiometer's scale to the scale that I want it to go to, and then put that into LED val. So then when I write analog right, I'll put the LED pin to the LED val, it'll output at the proper scale. So the first numbers are going to be the scale that you're setting it from, and the second numbers are the scale that you're setting it to. And then the first number or first parameter is actually your variable. But it's very useful in a lot of like mapping for joysticks. Lots of use that for joysticks mostly as well, as well as like other things. All right, the if-else conditions. So you can execute conditions or statements like if something happened, right? So let's say if you read a button press, right, do something. That's basically what this is. So you got to make sure your statement in the if statement right here is a condition, is a Boolean. So I'll put a 0 or a 1. That's what if statement reads. So a simple one would be actually just reading a digital pin. If you put if digital read, let's say a button pin, that'll be either a 0 or a 1, depending on if the button is pressed or not. So if the button's pressed, it'll read that and it'll do whatever you wanted to do in these curly braces right here. And the else is if that didn't happen, then its default state is this. There's also if else statement or else if statements, which goes between if and else. So if this, else if this, and then else that. So you have little branches you can go off of. So some of your operators are greater than equal to, less than equal to. This right here is for inverting whatever you have. So if this is, it's called a not operator. So if the button is not pressed, then do this. So And you can use the exclamation point before whatever the say the digital read, and then it will invert that 1 to a 0 or a 0 to a 1. And these two are this is the AND operator, and this is the OR operator. So you can put multiple statements. So what happens if you have, let's say you want 3 different states, right? You want 3 different buttons to press. If these 3 are pressed, and only if these 3 are all pressed, then you want something to happen, use the AND operator. So what the AND operator does is only if the 2 statements that's around, because you put a statement before, a statement after, they'll put the letter AND for a third one, let's say. So if those 2, let's say you have 2 inputs for now. Yeah. So if those 2 inputs are both high or both true, then it'll output a high or a true. Right? If those 2 are not, so if this and this, but the other one is not a true statement, then it will output a false or a 0. The OR here does it, or if something happened, or if something else happened. So if either of those 2 are true, then it'll output a true. I should have put a truth table on there. I just realized, so I'll put that in the PowerPoint afterwards. But yeah, I hope that made sense. Is everyone good? All right, cool. All right, the for loop. It's also a very commonly used loop here. And it's basically a iterative loop that will run the lines of code for a certain amount of time or some amount of times before stopping and then continuing on with your rest of your statements. So you can use this to, for this one right here, is a stepper motor driver. So I'm telling it, this loop right here to run the stepper motor 7,025 times, or this line of code, at least 4 lines of code, 7,000 times before it can write as high and then delay for a bit and then run it backwards. So, yeah. So you have basically 3 main things for the for loop, which has the variable, the iterative variable. If you don't have one already defined, then you can define it here using int I, or if you have int I equals 0 out here, you can use I equals 0 to set it as something. Then you have the condition, which is while I is less than step. So if while the iteration number is less than the total iterations I need, then add 1 to the iteration at the end. So what will happen is it'll first define I as 0. Then it'll look in the condition, is I less than 7,025? And it is. So it'll run these 4 lines of code. Then it'll add 1 to 7,000 to I. So now I is equal to 0 first, right? Then runs this. Then I equals 1. It'll go back up, and then it'll ask, okay, is 1 less than 7,025? Just yes. So it'll do this again. Add 1 to I. So now it's 2. I'll go back, and again, same thing. Is it less than step? Yes. So it'll continue this until I is 7,025 down here, and it goes back up and asks, is 7,025 less than 7,025, which is not true. So then it'll exit this loop, and then it'll go down to this, and it'll come back to this again, where it has to do it again. If you define a variable right here, this variable only exists within this function here, or this for loop. So outside of this for loop, that variable is gone. It's missing because it's a local variable to this. So let's have to define it again down here. Are you following along? All right, cool. All right. Next is void. It's really useful for making your own functions. Usually most definitions for functions in Arduino are at the bottom after your loop. You can define them down there and then put them back up. wherever you need them to be. So you just use void and then the name of the function you want to make, and then curly braces and put everything in there. Void is used for creating functions that have no returns. So it doesn't expect to return any value back. It just wants to execute commands and continue on with its life. There are other functions. If those who are experienced with C and Java, you also know how to create functions that do return variables. They won't be using void, they'll be using the actual data type. But that's like for a different day. But yeah, it's useful to organize your code so that everything is nice and clean, and it's easier to locate certain things, because it's a lot harder to go through your code if everything is one jumbled mess. One example I could show you is actually my code right here. So in my void loop down here is actually only four functions: check serial, fill LEDs from palette, and then just two for the LEDs. So for my table code. But the big function is actually this one right here. So let's go down there. That one is right here using void. And then inside of this one is actually more functions that I created, talking about more different intricate parts of the code. So it makes everything a lot more organized, having those functions, named my custom functions. Sorry.
Question.
Yes.
What do you mean by that having a void does not return a variable?
So in programming, we have certain returning functions. They'll use the return command to basically what will happen is if you run that function, you can set it a variable equal to that function. So at the end of when you create, it'll return a number or whatever variable you're returning. You can set that equal to a different variable. It's like, so void right here, it just does what it wants to do, right? It's little code, and then continues on. What so other functions do, if you have, let's say, an int instead of what you had int fry, right? Then this function here expects to return back an integer. So you have to use the return command for an integer. And then when you run your code, when you call your function, you can set an integer variable equal to that function. So whatever calculation it creates, right? Let's say you're doing a calculator, right? Your calculation right here will be returned back to the main your main loop, so that you can use it for something else, or your main wherever you're referencing it. That makes sense. It's like when using the calculator itself, right? The calculator app on your computer or your phone. You do a function and you see the number that you get back, right? You can choose whether to use that number that you just calculated, or you can continue on doing a different calculation. So what the void function does, or the void definition, is you do 2 + 2 + 4, and then you forget about it, kind of thing, unless you store it somewhere else within the function itself. But if you do, let's say, int instead of void, you do 2 + 2 = 4. Now you want to use 4 for something else, for let's say a bigger calculation. Does that make sense? Or
Yes, and then when you return that variable to that name, you just use that name in anywhere on your code
yeah,
and other functions.
yeah.
Okay,
So I think
cool,
I
understood.
might have a code. Let's see. I might have a different language, but I think it'll make sense there. Let's see if we can do this here. So it's for something else. Maybe if I remember correctly, it might have it. I hope so. Not here. Okay, if I find that code, I will show you that code. But yeah, anyway, those are some basic stuff, I would say, just to get your own program running. So let's start simulating our own Arduino circuits. You guys go to tinkercad.com or the Tinkercad right there. So tinkercad.com, I'll post it in the group in the chat as well. You guys can look at. And then you can create, if you have an Autodesk account, you can already sign in. If you don't, you can create one. Yeah, I'll
Quick
show you.
question, sorry.
Yes. No problem.
Does the Autodesk Tinkercad does it
Mhm.
have a STM board there too? Or nuclear board?
Um, we can check right now. We can
I-
check. I'm not sure. I don't never really use the STM boards on there. So
do we have to pay for that?
no, it's free. Just
Okay.
sign up with your personal account and then you can do it. So I have one from my previous one I can show you right here, but I'll create a new one as well in a bit. So while you guys go and create your accounts and then get ready and logged in, I'll show you this thing I did for my senior year of high school project, which is basically an LCD and a button to detect computers. I don't think it really worked, but you can see the code that I wrote right here. And then if you run it, you can, ooh, okay, let's find the floor. Um, oh, okay, it's fine now. But yeah, so the LCD returns on and it has different array of elements on there. About the STM though, let's see. Um, um, I don't think it, no, it does not. I think it only has Arduino boards. That too just means the Uno, I think.
Could you try typing nucleo?
Nucleo? Nope.
Nope. Okay.
Yeah. But let me know if you guys are all, logged in and everything. We can do a small circuit for next hour. So just let me know when you guys are all settled in onto the dashboard right here. Because you can do 3D models as well, some basic 3D models as well. Right. Let's see. Or have I used return? I'll find it on the side. Mhm. Yeah, are y'all ready? All right. We'll wait a little bit more. Wonder where it is. Yes, senior year of high school. All right. Right, big games here. Okay, I want you to see real quick. Right here, they use the return right here because it returns an integer. So I calculated, so I want to find the maximum numbers in an array or in a list, right? So it does a calculation, and then it will return the number of the maximum number down into, let's see, where's find maximums? It's over here. So see, maximums equals to the find maximums function. So whatever find maximums calculates, I put into a new variable in my main method. Does that make sense?
Yes, and you have that you have that return function.
Yeah, right here.
Uh, that return function, you can still have it on the while loop. You just they just make that function just to make the code cleaner.
Yeah, because I'm going to use
Oh,
it multiple times. So I use this find max function twice. So without typing the entire thing twice, I just wrote the function name twice because it makes life a little bit easier. Also, it'd be a mess if, let's say, I did this get menu option on top. Instead of using user in equals get menu option, I wrote all of this and then wrote all of this, or even, let's see, this one right here is void. That's void double. Basically, like there's a lot of functions that would make everything a lot more complicated in the main function if I didn't make smaller functions for them. It make the code hard to read and hard to fix if there's a problem with it because I don't know where it is. But yeah, that's that.
makes sense. Thanks.
No problem. All right, are we all good? All ready?
Yeah.
All right, sounds good. All right, let's create a new circuit. Let's draw here. Since, let's see, how many of us do know some electrical knowledge of like components and whatnot? All right, you need to know the basics. So as long as you know the basics, you're good. All right, so let's first start off with an Arduino itself. So right here, just change your components from like to all, just so they have access to all of them in case they're not originally there. And you can search up, let's say, breadboard, like a small breadboard mini. We'll do a small little one. Actually, no, small. We'll do breadboard small because we have more pins. Do we all know how the breadboard works and how connections occur in a breadboard? Okay. Just in case for those who don't know or reviewing this later on. So these 5 right here are kind of as one bus. And so you can kind of like 5 components to the same bus line or same line, same circuit. There's a few of them going across the entire thing. You also have the main power bus line being the negative here and the positive. So you can just put different pins of components across different rows. Yeah, okay. Yeah, one of these, we'll get an Arduino Uno. So just type in Uno, we'll get an Uno R3. They're very basic. So you can scroll wheel if you have a mouse to zoom in, zoom out. You can use the left mouse click to pan across, or right mouse click as well, or middle mouse click all right. So there's your Uno, there's your breadboard, oops. And then we start creating, let's say, let's do a simple circuit, okay? A simple state. We're gonna press a button and it will turn an LED on. And if you don't press the button, it will not turn the LED on. All right. So do we know how to say it normally? How you can do that? Actually, that's the LED part later, or the button part later. Let's say we just want to make the LED turn on and then off. A blink circuit, okay? So let's first talk about our bus lines. Let's power our bus line with 5 volts. So we have a 5-volt wire. You can left click onto it. They can drag it wherever. You have to hold it, by the way. You can just like move it. And click it once to create like a elbow. And it's like aligning it usually. And then click it again. And then bam. You also alter the shape later on as well. And then if you click on there, you can also change the color up here. Say so red for power. You make a different type. But yeah. And then let's do our ground on this side. So see there's a ground pin right here, or GND. There's two here and there's one on this side. So you can go here, ground pin right here. And then let's put on the other side. Just so we have that as why. We can also use it for reference later. So now let's get an LED. So a normal LED looks like this. Kind of, you can put it anywhere you want. But for now, note that this bent one right here, that's going to be your positive end. And the straight one is your negative end. Right? So you want to, you can put like this. You just drag it onto the actual points, or you can put wires to it. I'll just put it the points and say right here, just so I have access to both pins. So we're gonna feed in power from the Arduino itself, so that it can actually power an LED. We'll choose pin, say 3. Okay, pin 3 is gonna be our power. So that will go to the positive end of this LED. Actually, I'm gonna click the LED and just flip it, just so I can, make a nice little circuit without having any overlaps or anything. So I just press this mirror button over here. There's also rotate up here as well. You can rotate this all around. Oops. Yeah. There. So pin 3, and then we go down here, right here. And I'm gonna put that as yellow for data, because then there'll be our data out for the Arduino itself. And then right here, I'll go to the ground minus, like that. If anyone who knows like electronics, is there something wrong with the way I'm doing this right now? Correct. You need a resistor. If you don't use a resistor for this, so again, like Ohm's law here. So there's some resistor here, and there's some internal resistance of the actual LED itself, but it's very small. So what will happen is this will draw a lot of current that will end up causing an explosion. And you can actually see that if you program this later. So we'll program this right now without the resistor, and we'll see what happens to the actual LED itself. All right, then we'll put a resistor on there with the proper resistance on there. But that's going to be your basic circuit, but with a resistor. So I'm going to bring out a resistor here, and we'll look at this. I'm going to add to the circuit so that it will make sure that we don't explode it. All right, and then so I'll move this back a little bit so that I can use the still space for the resistor itself. I'm going to rotate it, and then I'm just going to put it right there. Ooh. And go back one more. And there. So this resistor will be, I'm gonna put it at 220. For most LEDs, you have 220 ohm resistors, which is typically pretty good for 5 volts. If you look at the calculations, let's see, right? So since it's a series circuit, so that voltage won't stay the same, but current will. Let's see. But since it's a simple 5 volts, so 5 volts divided by 220, it's about 0.02, which is 20 milliamps, which is what you want for turning an LED on, because it turns on at around 20, or it draws about 20 milliamps for optimal. You can also go by 330 30 ohms, which will give you well under it. It's fault safer. 220 is pretty good. I use that more often, but 230 is for like, you want to make sure your LEDs aren't gonna die out fast. 230, we want to go for 5 volts. So I'll put 220 for now. And then let's do some coding. So you see it's code blocks right now. If you want to do some more fun stuff, you can use text. And they actually have it already. The code already set up for you for the blink circuit or a blink code. The only problem is you don't have is the proper pin. So they use LED built in, which is the built-in LED right here, pin 13. So we're gonna put that into pin 3 instead. So I'm gonna delete all these LED built-ins because they're not gonna be the ones we're gonna be using. If you guys want to challenge yourself, you can just delete all the code and write it all yourself. But we'll do some modifications later on. For now, let's go up here before void. Does anyone want to tell me how to define a pin? A variable, let's say. Because I want to name this like LED pin. That's the name I want to get the pin. Yes, I'm asking for a variable name. The variable name is going to be called LED pin. But how would I want to define this variable name? How do I go about that? Yep. So for pins on the actual Arduino, I recommend you guys use the hashtag define. So write that hashtag define. And then we'll say LED pin, pin 3. No semicolon for how we're gonna do this, okay? Let's say this timing right here. So let's make our own variable for the actual delay of how long it will blink for. How do we define a normal variable name? It's going to be an integer because it's going to be a value that's not a decimal point into our. Okay, so let's do int say time. I think time might be a keyword in Arduino. Maybe I'll put 2 e's just in case. All right, and we'll set it equal to how long do you want to make it blink for, or wait and blink. So it's pauses. So how long does it stay on for? How long does it stay off for? Do you want to wait for 1 second? Want to wait half a second, 2 seconds? So one thing I found note is that the delay function here is in milliseconds. So you have either milliseconds or you have the delay that's also in microseconds, which I use for something else. But you don't have seconds and stuff, you have milliseconds. So how long do you want to make the LED blink for? 1 second or 2 seconds? We are having a war. 1.5 seconds? Let's do 1.5 seconds. So time is equal to 1500. That's 1.5 seconds. All right, and we'll put in the digital right here, we'll type in LED pin. You can also type in the actual number 3. That's pin 3. It'll also work. But I like to keep all my variable names so I know what they're, what I'm referring to. And then in delay, I'll put time with 2 e's because that's my variable name. Remember that variable names are case sensitive. So yeah. Okay. So we did that. So let's run this and see what happens. Let's see if I'm missing anything. I'm missing anything. Oh, semicolons are also important. Oh, I forgot the pin mode. Pin mode is also important. Okay, so let's do this. That's also LED pin. Okay, make sure you're not missing any semicolons. See if in the comments so you can know. All right, that should be good. Let's start this or not. All right. It may be that on your CAD, you can't use hashtag define. So we'll just do the normal way. Const int LED pin for the 3. So there we go. So you see how it's blinking for 1.5 seconds. So let me know if everyone else's works. Give you a nice little blink going on. Working nice. All right. I hope everyone else is working as well. So if I were to say take out this resistor right here, and I just, I directly connect this to this. Let's see. See that error pops up right there? So let's talk about that error. So current through is, oh, my thoughts. Oh, there's an error though, and I don't know how to see that. Yeah, so it's 50 milliamps it says, which is a lot more than 20 milliamps that you need to run the thing. So this is bad for the LEDs. It will overheat and it'll burn out a lot faster than you think. So it's always remember to make sure you have a resistor. In some cases, you're gonna need resistors to keep things more manageable in terms of fires and whatnot. So yeah, if you were to hook the LED straight from power and ground, it will cause this to explode. There we go. There's way too much current going through the LED that it can handle. So it'll tell you when you made a mistake. So yeah, you don't want to do that. In real life, it's kind of bad. So yeah, all right. Like that. Let's modify this now for that input that I was talking about. Or let's do a potentiometer. So it's right here, or you can search, I think, in your basics, it's right there too. So this right here has 3 pins for positive, negative, and then your data output or your resistance. This is a variable resistor, so it can basically act like a dimmer switch. For a normal circuit, right? If you don't have an Arduino, you'd probably just hook up the Viper here to the LED, and that way it'll dim. So let's do that first. So we don't need this at the moment. We'll just do this. We'll disconnect the resistor for now. Put the terminal 1, let's say, into positive. So I'm at a bus line right here. Stick all the positive bus lines, all negative bus lines hooked it together. Okay, so terminal 1 here goes into positive. Let's make that red. Terminal 2 here goes to negative. Let's make that black. And the wiper here can go straight to the LED. So see, it's broken right now because it's at 0 setting. So let's bring back the resistor. Yeah. Let's bring back the resistor right here. And then I'll just disconnect this right here for now. Oh. And make this right here. Wow. There we go. And I'll make this into data for now. Orange. Okay. So when you're gonna rotate this, you see that kind of dims out. I hope you're all like working the same way. So this right here is just used for an LED, but if you want to read these values into the Arduino itself, then you can do a little bit more than just dimming this LED. You can use it to calculate other things as well. But for now, let's do the same exact process here, but with the Arduino also. So instead of here, what we're gonna do is I'm gonna bring this actually down over here and rotate this so I can kind of have it down here. The same as we have, say, positive, negative, and then our wiper here is going to go straight to A0. So that's red, and that's black. Let me know if I went too fast, by the way. So slow me down or ask me any questions. And then right here, we're going to go back to pin 3. That yellow. So are we all here? I'm gonna wait a bit for you guys just to catch up in case. Let me know if you guys are all at this level right here. All right. Anybody else? All right. So when you first start the simulation, then you can turn the knob just by dragging it. Just drag it. All right. We're all good? I'm gonna assume yes. And okay, let's do some coding now. Okay. So this time we have A0 for our potentiometer. So does anyone wanna help me program the variable name for the potentiometer? Yep, perfect. What's that? The const int top pin equal to A0. Right? Even though this is A0, you can use int because the Arduino will convert A0 to the actual GPIO pin number that it is. So this was, I think, 18, 19's over here. Is 20, 21, 22, like 23, something. So you can also use the GPIO, like its actual pin number as well. But for now, it'll be easier to use A0 because we know exactly where it is. Okay, so let's pick a new value, this new variable for what the value of the potentiometer is. Does anyone want to program that one?
Question.
Yep.
What was the time for again?
The time here is for the delay. So the wait time for the blinking. So it's in milliseconds. We'll use like 1,500 instead of 1 for 1 second. Then,
You're basically just doing a PWM on that, right?
no, there's no PWM just yet.
Okay.
So I guess in a way, actually, yeah, because this is time high and this is time low. In a way, but it's not that fast. You wouldn't label the potentiometer as a double because there's no decimals. So it's still int. Nope, it's gonna, oh, well, you can put a default value of 0, but yeah, it just int, let's say val, right? You can put val for now. So that's because we're going to define that in our actual loop. Okay. So how do we program the pin mode of the potentiometer? Is it a, how do we do this one?
There's definitely a map somewhere.
Nope, there's no mapping yet. Yep, okay, so let's do pin mode. Plot pin, oops. Plot pin, input. So that means that that pin right there is an input and it's going to receive data. Okay, so what do you want to do with the potentiometer? We can do the normal one, the basic of, we can use as a dimmer, right? But not using the Arduino. We can also, instead of doing a dimmer, we can make it blink faster or slower, or change its duty cycle, right? Time high or time low, right? So what do you want to do with your potentiometer? Since now we have a bit more capability than just dimming the LED. Do you want to still dim the LED? Do you want to change the timing? Blink faster? Okay, do you want to make it blink faster, but at a constant where the time low and time high are the same? Do you want to like vary both of them? So that, like, let's say the more you turn it, it stays on for longer versus, so basically doing a PWM signal, but like with just a potentiometer. Do you want to do both? Change the brightness and the blinkiness? There are a lot of options now. We have a lot more options. So yeah, to which one? I listed like a few. Both? Okay. So let's do both. Okay, let's do both. So now in this case, time is no longer a constant. So good thing we never put constant to start. Usually, because it was a constant for us, I'd put a constant up there, but I kind of forgot about it. That's not good, but it's good now that I'm going to use this for something else. So let's first start off with, I'm going to first read the value of the potentiometer, right? And we're going to set that to the value called val, the variable called val. So does anyone have any idea on how we're going to write this first line of code, which is just to read the potentiometer data and set it to value or val?
Do we have to use a loop?
It's going to be in the loop function because we want to constantly pull the pin for an update on the potentiometer, right? We don't want to just run it once. We want to run it continuously as long as the Arduino is on. So you can always change the potentiometer value, and it will change the brightness or and the blinkiness of the. Yep, that's right. Let's do that one. So val equals to digital read plot pin. All right. Now here's something that I want to use for debugging purposes. Right? We have something called a serial monitor. You see down here, serial monitor. Whatever data, like if you want to say read a value and tell you exactly what it's reading, so you don't know its current range, right? You can use this. So how we're going to do this is we're going to first, in the setup, we're going to do this thing called serial.begin. Serial.begin. This will start the serial communication between your Arduino and whatever serial device you're going to do it with. And so this 9600, that is the baud rate or the polling rate at which how many times it's going to be at what frequencies we're listening at, I think, if I remember correctly. So once you start the serial right here, then you can actually do is you do serial dot print ln, which means it'll do a line break at the end. and then you can read val. All right. So this right here, I'm just gonna put it right here for now. You can read what the value of the signal of the potential is going to be. So let's run this code right now. And you'll see it's 0 right now. And it's 0. Do you see how slow it's going? It's waiting for a bit. It's going with the actual blinking of the actual LED because of the delays that we have. Because the delay will actually stop the entire process of the Arduino since only on one processor. So if you gotta keep that in mind. You can't do long computation. It'll kind of hold everything back unless you know a bit more on how to optimize things. But if you change this value to a random pivot point, and now we'll see it change to 1. Sorry, digital read. It should be analog read. Yes. I was like, wait, yeah. So, good catch. Analog read. Let's do that right here. But you see, it's going from 0 to 1 because it was reading it digitally. Because you can use the analog as digital readers as well and writers. If you use analog and start this, now you'll see 941 instead of what we saw earlier. I'm gonna stop this simulation for now and just put the comment for the block comment right here. So slash and the asterisk and then asterisk slash at the end to comment out this block for now, just so I can just read this value continuously. So you see it's a lot faster now. I can, and as I change the value, it'll change. Or as I change the position of the potentiometer, it'll change the value it's reading. We see max value is 1023. It's like I think that is like an 8-bit thing. But yeah. All right, let's go back to this. So now that we have our value and it's properly reading this time, not digitally but analog, what's the word for that one? Anyways, yeah, sorry. So now we have our value. Let's make that into the time. So set the time. Do we want to just set the time from the value? Do you want to make it a range of times? So do we want to make it wait from 0 seconds to 1023 milliseconds? Or do you want to maybe map it out to, let's say, it should be from 0 sec or from, let's say, 10 milliseconds to 2 seconds? Do you want to map this out at with different sets, or do you want to just use the raw value as the milliseconds, and just use it for now? Raw value? Okay. Then just put, so let's put time is equal to value. And now the raw value is put into the actual time. For the dimming though, we have to map out the value to something else. So we can use the same variable to map this out, or we can use a separate variable called, let's say, LED val. Let's do that. Let's go up here. You can put on the same line, we can define multiple similar variables. So int val, comma, let's say LED val. So these two, both of them are going to be ints in that case. So you can define it that way too. So then get down here, we can do LED val is equal to map val, comma, what's the bounds for val? It's original set. Yep. So 0, 1023. And then we're going to map it out to the PWM's M signal. We're going to output on pin 3. do we know what the range is for that one or no? Yep, so it's 0 and 255. The 255 is going to be your usual for PWM signals, it's max and min. So this right here will convert the value to 0 to 255 because we can't go over 255 for an analog write. So we can convert this right here to analog, analog write right here, and set it to yes.
So could you
Mhm.
explain why you're not mapping the time, or you
So
don't map time value?
we don't need to map time if we don't really need to change its current range, right? So time right here, right at the moment, will go between 0 milliseconds to 1023 milliseconds. Because for a time delay, there's not really much restriction on how long you can delay it for. You don't really need to do it unless you want to do that yourself. Like if I want to change the range from 0 to 1023 to, let's say, I want 0 to be 10 milliseconds, and then its maximum 1023 value to be 1 second. If I want to constrain that range, then I could do that. But there wasn't really a need for it because it's only about the same as 1 second. And I also asked you guys, and somebody said they wanted just to use a raw value, then use a raw value. If you want to map it, you can't. You can definitely map it to a completely different range. Let's say I want the maximum delay to be 10 seconds. Then I would use map because I can't hit 10 seconds with just a raw value. Does that make sense?
Yes, thank you.
So this right here will be that LED val, and then analog write LED val. We can still use digital write for setting the LED back to 0 because it's a 0. Writing it to 0 or analog writing it to 0 will be the same thing. All right, so that's going to be your current code to start the simulation and then see what happens. Or see the 0, you see, as you increase brightness, you also increase the delay. And then as you decrease it, it'll go a lot faster. And you can see on the serial monitor as well because it goes a lot much faster. Are we all here? So does it work also for you guys? All right, cool. All right. Now we have that. Let's see, what else can we do? What else do you guys want to do with just a potentiometer and LED, or do you want to add a button to it too? All right, let's add a button to it. So this right here, push button right here. Let's bring it out. Push buttons are kind of interesting in the way that they work. You actually have terminal 1 and when there's 1A and 1B. They're connected together in one short circuit right here, one wire, and same with terminal 2. So when you want to push the button, if you put a signal through, let's say this right here, it'll go directly across to here. But if you press the button, it'll go to terminal 2, so it'll go on the other side of these two. So that's kind of very useful for what we're going to do. We're going to put it right here. And then we're going to put a pull down resistor here. So this right here, I'm going to put that's 1 kilo ohm, like it says up there. And I can put it on the ground. I can put this one as power. That's red. Okay, so you gotta choose. Do we want our default state to be high or low? What do you guys want to do? With the default state as high or low? Low? Anybody else wants to do high versus low? Okay, low it is. So we'll use the low side, so this right here. And we'll put it into, let's say, pin 2. Oops. If it is yellow, I should go orange. Or no. Green. Okay. I'll go down here. And do pin 2. Okay. So the reason I chose pin this terminal here is because it's automatically going to go to ground first by default. But if I press power, then it'll go to power and go this way. The reason I put this pull down resistor right here is because when I press the button, it's also going to make so when there is no power, no 5-volt signal going through, there's going to be some current that might leak through the connections here. So I'm gonna bring that down to ground. So make sure it's properly ground. There's no floating signals anywhere. Because without this, you could actually just like if you're in person, sometimes what will happen is you don't have a wire plugged in or anything, but if you just like go near it, you don't have to even touch it, just be near it, you can induce a signal. There's one time where nothing was connected. Or just wires sticking out. But if I put my foot, it had the heel of my foot was in the ground. But if I put the tip of my foot as well on the ground, it will light up an LED. And I was nowhere near it. I was sitting like far, I'd say like the table is a little gap as well. But it still induced the current by just touching the ground with my foot. So that's why these pull down resistors are important. Just to make sure that signal is either a proper 5 volts or a proper 0 volts, nothing in between. That could possibly cause some confusion in the data. All right. So back to our code. Since now we have a button, we're going to have some conditional statements. So let's do that. So now with a button, we can actually do a little bit more as well. Do we want to, if we press the button, do we want to toggle it on and off? Or do you want to just turn it on if you press the button? Do we want to keep the previous code of blinking as well? So when you press the button, it will blink the LEDs, but if you release it, it's going to turn it to off. Or it'll leave it on. Let's toggle the blink. Okay. So when you press the button, it will turn the blink mode, then press it again, and then it will turn it off. Sounds good? All right. Let's do that. So first, back to our pins again. Does anyone want to take a guess at how to name our button? How to give it a variable name and also a value? And we can do 10. We don't need a PWM though. I'd say let's do 4, pin 4. It's right there. And then we're not raise up button pin 2. Yep, that one also works. Let's do that one. So well, not as a pin 2 because we already have pin 2. I did use pin 2. I didn't even see that. Wow. Okay, let's do that. So constant button pin equals 2. All right. And then we got to make a new variable called, to say, tog, right? So it's comma tog. The toggle is going to be our toggle. We're going to actually set its default state to 0. So I'm going to put it at 0. That way, it's going to be on off when it first sets everything up, right? But also we'll do some stuff in here as well. So how do we define that pin 2 is going to get a signal that's going to be a 5-volt signal? Yep. So pin mode, button pin, input. Now, if we chose to use this pin right here, then we would have put input pull up because our default is 5 volts. But when you press the button, it's going to go to 0 volts. That's going to use input pull up. But for this one, it'll use input by itself. And then right here, let's do statements. We have to first read the button value. So that's also one we also need to do that too. Let's do that. So I'll call it button. We're gonna view T val, not val. That way we know what it is. Okay, so we use input pull-ups for when our default state is going to be a high. So if instead of the pin 2 being the terminal 2 on this side where the resistor is, if this was actually on this side where 5 volts is a default state, so when you press the button, it's going to go to the ground. So we got to pull up the internal when it senses the data, it'll basically output a 5 volts on pin 2 using input pull up. It'll output a 5 volts so that when it goes to ground, when it sees the ground, when it goes to 0, it'll detect it so that there's a signal there. That makes sense? Yeah, because like certain things also just output a low instead of a high when they're on, or if it detects something. Like let's say like your garage door laser, right? Its default state is the laser going from left to right, so it's hitting the receiver. And then when there's a break there, then it can't receive any data. It'll output probably a low or something, and then you can use that to use input pull up, and then use that to do something with it. All right, back to this one here, button val. So how do we read the button? Yes. So the code's going to be button val is equal to, we shall read, and do button pin. Now we'll give, so I'm gonna also just comment out the serial line right here because we don't need it anymore. So I'll keep the serial is in there in case we do want to look at something for debugging purposes. And now let's say if statement here, so that if the button is pressed, it will change the toggle to a different state. So you have an if and an else right here. Does anyone know what goes between these two? Or oh my. Okay. Okay. So we'll do if the, let's say, val equals 1. Yep. The default val is equals to 1. Right. That's something from the slides I forgot to list is when you're comparing something to equal something, you use two equal signs because one equal sign is for assignment, but two equal signs is to compare whether one value is equal to the other value. So if val equals 1, then tog. No, if val equals to 1, I'm gonna put a parenthesis inside of it. But and gotta make sure that if toggle, is 0, then tog will equal to 1. And there's not same thing. So, and then else can use high. You can use high. Actually, I think you can use high, but I prefer to use the binary zeros and ones. It's a little bit easier than typing high there. But I believe you can. Don't quote me on that though. I rarely used high in a comparison. Okay, we're gonna use else if here though. Else if, let's say if but value is still pressed, but tog is not equal to 0, tog equal to 1, then we'll write it as tog equals 0. All right. Just to test this code out, I'm going to again comment out the actual LED portion and just use the serial monitor to see whether what logically in my head works. Will it work with itself? So serial.print ln, and let's type in tog and see what happens. Okay, but before we do this, after we assign but val, we should debounce it because there's some small little like vibrations in the actual button as well that could possibly be read. So when you're doing it in real life, you want to also might want to delay microseconds. Oops. And then do like say 200 microseconds, just to like kind of bounce out vibrations. I don't know. Tinkercad has microseconds, but we'll see. All right, cool. So you see 0, do it once. So I see 1, 0. So there you go, 1. And then click, see 0. So you kind of like give the press kind of a little bit than just one time. That might be the actual debouncing over here. So I'm just gonna see, maybe it'll work better. This 0. Yeah. So it won't really read it. So we need a higher value here. There you go, 1. And still hold it for a little bit, but it'll should be it soon. There you go. Yeah, you gotta find the right value to kind of buffer out the reading and then the actual, so you can actually read what you when you pressed it. But it does work. So then we can make our other if statement right here. Let's actually create our own little function on the bottom. Let's say the LED blink function, right? Right here. Since most of our variables right here, LED pin, LED val, they're all global. So they're all up here outside the void setup void loop. They can be accessed by any function. So we can cut the avoid the LED link. And then that. We can actually just copy paste all this into here. And then we can use LED blink instead to create. We can just put right into here. If toggle is 1, right? Then you get LED blink. But if it's toggle 0, then you can do digital right. LED in or low or 0. So let's see if this runs. Nope. Okay, let's see. LED pin low.
Is it because it's a digital, right? And not an analog?
No, that's not the reason why. What's this? Because it does work without the function itself. If I were to just copy paste this, or like, oh, I think it's my computer. Let me refresh it. Like sometimes it might like buffer out. That could be the case. But let's see, it does the same problem again. See, it doesn't. Okay, so it's fine. It's just the site. Okay. And yeah, so click on it once, and now it's blinking because 1, and say blinking. Not. All right, that's because this is only if the button value is being pressed. You see? So this made sense in my head, thinking that if I press the button, then toggle will be 1, then everything will be fine. But actually, they should be in a separate function, a separate LED different if statements. So we can do that. Let's do this, do this, and let's create our own thing here. If tog is 1. So we actually use if tog by itself because it's 0 or a 1, right? Just all we're doing is 0 and a 1. That is basically what this is, what Boolean is, right? 0 is false, 1 is true. So if tog, then we can do LED blink, else to the right, LED ping, low. Now run this and click on it. Now it should be blinking. Yeah, that was always blinking. That, and then you click on it once again, and there is 0. I have to find it. Because now it's fighting the different delays. So if I use this faster, and then you can see the different timing is important for buttons, for reading the button values and everything. But yeah, just gotta know when to pull for the right thing. So that all that it can be fixed with this right here. You gotta figure out exactly the timing for this, but it does work. So that's toggle. But the delays with right here as well is kind of hurting the ability to actually press the button when it's doing it. All right. There's also a different set of statements for like more advanced people, or to switch the case. Yeah, switch in case. Because this is 0 and 1, 0 and a 1, you can also use those. They're a bit faster. But that's for like when you're a bit more advanced, I would say. But yeah. Any questions, comments? Any But yeah, so we have 10 minutes left in the workshop. So does anyone want to do anything? Like you want to tell me to like try something, make something? Any questions, comments I can help you with? All right. Well, thank you guys for coming to today's workshop. I hope it was informative and hope you guys learned something from it. If I went too fast, do let me know so I can like, work on it as well. Feedback's always appreciated. So yeah, thanks for coming again. Yes, there will be the actual physical building next Friday. I will be bringing some Arduinos. I just have to solder the actual pins to them, but I'll be bringing those next week, and then we'll be creating what the soldering kit. So the piano that we made for a soldering kit, we'll be remaking that with the Arduino. It actually uses an Arduino by itself. If you guys have seen the soldering the soldering kits for this season, the Arduino is actually right here, a small one. It's a smaller Arduino that we pre-programmed for you guys to learn. That's for soldering. So we'll actually code this ourselves for this coming Friday, as well as any other projects you guys have in mind. If you guys want to try something else. But yeah, now there's this. That's that. So I hope to see you guys again on next week's workshop. It's been a bit more fun, more hands-on. It is a lab. You can see the Arduino itself, or a type of Arduino that we have, and build them yourself. Yep, you can do that too. Just like different ways of like accomplishing, like fixing those. But yeah, I just didn't go over much. But yeah. No, I want something different for this year. We'll be kind of relating every workshop a little bit to the other workshops. So if you've been to the past workshops, you've seen how the 3D modeling one made the case for the soldering kit. So next workshop is going to be about creating the actual piano that we made for a soldering kit. So we'll bring buttons, we'll bring little buzzers, you guys can program as well. So you can make your own little piano that's completely out of tune. It's, up to you guys to make those. If you guys do want to do other experiments with the Arduinos, yeah, I'm open to that as well. So yeah, have some fun this coming Friday. No problem.
I have a question, but
Yep,
I'll just wait for everyone to leave, or if anyone else has another question.
no problem, guys. Thank you guys for coming. But yeah, you too. Thank you.
Okay, so
Yeah.
do you have any experience on coding for nuclear boards?
No, I've never
Using
heard of them actually. Let's see.
they're they're
Nuclear?
they're basic they're basically like
Mhm.
like an Arduino, but I think like their
Oh,
computation might be a little faster.
uh-huh.
STM, yeah.
Mhm.
Are you a ECE student?
No, I'm aerospace.
Oh, okay. And for you guys just mostly use Arduinos, right?
Well, we don't use any of this to be honest. I'm just doing it because it's like my hobby. That's why.
Oh, cool. Oh,
Yeah.
well, you should definitely look into these boards. I think they're a
Yeah.
little more powerful than the Arduinos, and you can do a little bit more with these. Oh, but these ones are more they don't really have like an open source. They're not really
Yeah.
so much open source thing, but I think the Arduino stuff kind of you're able to like translate to these boards somehow, and that's kind of what I wanted to ask you if you
Hmm.
some questions on that. Yeah, these are
Um,
pretty big on on the or for embedded, yeah, embedded systems.
yeah, looks very interesting. Wonder. um, hmm. Oh, there's C++ as well.
Yeah. The
So that's
languages, yeah,
pretty.
C++, yeah. It just
Hmm.
I just the configuration and the peripherals are
Wow.
just a tad different, but I mean it's like
Yeah.
mostly just the same concept.
Yeah. I see. Maybe I'll look into just like having one just to have fun with.
Yeah, I think I think what's out there more it's the for the software they use is Cube ID.
Cube ID. Uh-huh.
Yeah, Cube ID. You gotta, yeah. I mean, yeah.
Cube ID. Whoa, okay. Oh, based on Eclipse, okay. Hmm. That is like, yeah, look at documentation. There's some, yeah, I have no idea. I've never seen this thing.
No, yeah, no, it's okay. No, I was just wondering maybe because you seem like you know a lot about the Arduinos and because
Right.
because I'm actually I was trying to do this. I was trying to use this board for one of my projects,
Yeah.
but then we kind of just realized just since Arduino has an open source,
Uh-huh.
we're just gonna use an Arduino instead. But because I was having some trouble with this, so I kind of just wondering if maybe you probably knew, but it's okay. No big deal.
Yeah. I have some
Uh,
research on this and like if I ever have one, then if I look into it, then maybe I'll know. But like, yeah, at the moment, I don't. I might know somebody who knows a bit more about it. I can, you know, you can give his DM or something
yeah,
like.
yeah, no, it's fine. But if you are looking to get a board,
Yeah.
The Nucleo dash C06, it's
Uh-huh.
really affordable. That way you don't like have to spend too much money on it. It's a C06.
Oh
Yeah, I
man.
think
Okay.
they're a couple bucks. I think they're like, yeah, 20 bucks around there somewhere. You want to start off with it.
Hmm. Yeah. I'll look into that. Thank you. Looks
Yeah,
interesting. We need to find more boards to mess around with. So
sounds sounds
yeah.
good. All right, man. You have a good one.
You too. Have fun. Yeah. What's up with that one?
I think can you like go I think this was in the beginning though, because I came a little late because I didn't know this was gonna be on Zoom.
Oh,
Um
that's okay.
but I think just like in general, like
Hmm.
uh I think so like how it was how do you like connect the 5V volts, so like the pin out to uh the breadboard, but
Yeah.
like so where is that connection? So like you said that the 5e to the positive, right? But
Yeah.
and then on the other side you have the pins, right? Where you connect it to the LED, right?
Yeah.
But like where's the how is that even connected to like the like because you have one side where the 5 volts is connected to, and then you have the other side, but how is that connected to the pins? Like how are these like uh connected, if that makes sense? I think yeah, like
Okay. So here, so for the 5 volts on this rail right here, right?
mhm,
And this rail goes across the entire thing. And then I put this red right here that goes to this other rail that goes all the way across, right? That's your main 5 power. Same for the ground. The ground goes all the way across, goes down, all the way
mhm.
across. So both rails power and ground.
Yeah,
Um,
uh,
talking about these rails right here.
Yeah, like okay, so like you connected like I understand like how you connect like the ground to like the ground and then like your
Yeah.
voltage, but like so like from the other end and then going from your digital pin to like your
Mhm.
LED, right? So like was it because you connected? Because I didn't see that at the beginning, that's why I don't I wasn't seeing like how you
Oh, so do you know how the breadboard is layout is or
no
no?
yeah
Yeah.
yeah
So
but
it went from the pin went down to this one here, the resistor, and then to the first the positive side of the diode, to the that one. And then it goes to ground on the other one with just jumper wires.
oh wait oh, okay wait because I think so like
Mhm.
oh okay that I think oh yeah so like okay so you know how it's connected to ground like that
Yeah.
but how is it like how is it connected the from the other side the positive or like the your electrical current so how is that connected from the other side like that's where I understand the ground part but
Yeah.
like where's
So
the
where the 5 volt coming from? Where's the 5 volt
yeah,
charge?
yeah. So like
Okay,
it's
okay.
connected to the pin,
Yeah.
and then you have from the other side. The other side is it has the 5 volt, but like so yeah. So it's just up to the pin part is where I don't understand.
So
Like
like where's the
connected.
5 volt coming from, right?
Yeah,
So like
yeah,
because there's not gonna any 5 volt bus line or anything. So where's the 5 volt coming
yeah.
from? So the 5 volt's coming from the actual Arduino itself. So these pins right here, when you set them to output, they will output a 5 volt uh voltage at like about 40 milliamps or so maximum
Oh,
current
okay.
draw. So one LED is fine, because it can support the two LEDs in series
Oh,
or
okay. Yeah,
parallel.
that's what my question was because like I understood that it was like coming from ground and then going up to the like the positive, but I didn't know
Yeah.
where that pin was coming from, like where the how you it
With
was connected.
Yeah, it's from the actual board itself. So this right here is a processor right here. So the main power from here goes into this thing, and then it also outputs. So
So
this
then
right here is the power. Yeah.
So then what's like the purpose, like going down here, the 5 volts? Like what's the purpose of connecting it to the board? Wait.
So I want the 5 volts to connect so I can power let's say the resistor, the potentiometer
Oh,
right here, right?
okay.
I want
Yeah.
the 5 volts as a signal for the button here as well.
Oh, okay. Yeah.
So I need those because so if I don't have the 5 volt here, then the button can only output ground, right? So
Okay.
then
Yeah.
the input will be nothing because there's no 5 volts to like,
Right. Yeah.
yeah.
I
So
think because like at the
mhm,
beginning what I was seeing like
mhm,
so like this top part where like the so you connect the digital pin
yeah,
right from there up to like the LED and then your ground like back right so
yeah,
like all of that because at the beginning I saw that you had the 5 volts like
mhm,
connected to the breadboard
yeah,
but like that's where I was confused because it was just that connection from the 5 volts to the breadboard and then you had this like top part up here like all of
yeah,
that so like
yeah.
I was kind of confused like like can't you just do like the digital like just this top part can't you just do it like this
You can, yes. I just
okay
I just had the 5 volts for everything else because they need the external power.
okay because like yeah so it's just like in order
Yeah,
to just have your whole like circuit or like so you could just put like you could just set your digital pin like right here and then
yeah,
all the way to the ground right just
yeah.
this top part okay
You all you really need if you want to make the LED blink by its like just with the internal power it has, all you need
Mhm.
is the yellow wire and the black wire, and that's it.
Okay
And the
yeah
resistor. That's all you
that was
need.
my question okay
Yeah.
all right thank you
No problem.
thank you
Thanks
so
for
much
asking. Yeah.
yeah thank you bye
Bye-bye. All right. Any other questions?
Can I double check the code because
Yeah.
my button doesn't seem to work?
All right. Here you go. Or it's kind of long. Okay, let me just, there you go. Um, I'll put it into Notepad that way. Or yeah, I can just open up this right here. Okay. There you go. And then it's full screen. That's the entire code. Yeah. What kind of error does
Question.
it give out? Oh yeah.
No, go for it. Go for it. Finish.
No,
What were you
Uh,
saying?
no error. I had an error. but
Uh-huh.
that was because I was rushing to finish the code, but it works. It's blinking. I mean,
It just doesn't read the button again
or
afterwards.
as in like if I restart the simulation, I could click the button, it starts blinking with like the potentiometer and stuff.
Yeah.
But if I click the button, it's supposed to toggle off.
Oh yeah, that's
Right.
because you have to right now in its current state, you have to put the potentiometer like a lower value so that because we put the the delay also with the potentiometer. So we need to lessen the delay so that it can catch when we press the button. So just twist your potentiometer to a lower value and then try pressing the button again. It should work, but like it probably does work. It's just that the current delays right now in the code are causing you like whenever you press the button, it doesn't read it. So I think in more advanced coding, you'd probably make it into like an interrupt so that the Arduino knows what it does. And then when you press the button, it interrupts whatever it's doing because it pressed the button. And that way it'll definitely read your thing. But for now, like in the way that it is, the delays are like it basically stops the program from running for a bit, so it doesn't read when you're pressing the button. That's what's happening.
One more time.
So, what's happening here in the code because there's so many delays right now. Whenever you press the button, the Arduino is actually probably on its delay, where it doesn't read anything, or it just kind of stops for a bit. It halts everything because of a delay for a certain amount of time. So it's not reading when you're pressing the button because the delay is kind of big. So lessen your potentiometer, like make it lower the amount so it kind of blinks fast but a dimmer state, or just to 0. And then you can press the button again and it should be fine.
So like delay microseconds.
Yeah, it's like if you see mine right now, my simulation right now. If I press it once, it'll work. But if I press it again, it doesn't work. The toggle's not working, right?
Mhm.
So what I have to do is we look here, look at the serial monitor. Every time I press the button, like it's not reading it because the delay is so long. So I'm gonna lower the potentiometer a bit. So it's being faster at dimmer state, dimmer state. I press it, it can sometimes read the 0 now. So I try to press it at the correct time or listens a little bit, press it, and then it should set at 0 at some point. It's almost there. But it's the current code isn't right now optimal for keep the toggling it off because it's just not enough, just not enough time. So now it's one. Yeah.
Well, so yeah, I mean, when I like hold it or like if I click it, I see like zeros, but it doesn't.
Yeah.
Maybe it's toggling too fast.
Yeah, or it's just not reading it fast enough, like, or it reads too many of them. Because that's the problem with the buttons in general. Because when you press it, even in real life, there's that certain like bounce to it where it might toggle your thing twice or something else. So a better way of programming this in the future would be to make it into an interrupt pin instead of this normal one right now. So an interrupt, it'll just kind of like interrupt the process or something. But yeah. Yours does work though. I'm pretty like if you can turn it on, you can probably turn it off. It's just the problem being that the way it's coded right now is not optimal for toggling it off.
Right. And then I guess just I might as well ask. My
Mhm.
potentiometer only works within the lower half, so from 0 to like whatever the 1/4 is. I'm
Yeah,
assuming that's just a website bug if I can't
possibly.
turn it.
So
Okay.
yeah, if you can't turn them, yeah, then that's like a website bug.
Hi. Yeah. Okay then. Thank you.
No problem.
Bye.
Thanks for coming.
Bye.
Have a great weekend.
You too.
Thank you. All right.
Question.
Yes.
So for the open libraries,
Mhm.
I seen that they have a few, like a bunch on their website, on the Arduino website.
Yeah.
do you know if there's any other sources where I can look for
You can
more
go
libraries?
onto the IDE.
Oh, okay.
So if we have an idea here is a browse the library manager, you can search anything you can think of. It'll probably be here. You can also look at GitHub, and then install. You can also go here to preferences, and then sorry, boards. For that one. As edit sketch. Include library, yeah. So when you go to GitHub, you can also add the zip file, let's say, or so right here, you can manage libraries, and it'll open up the library manager tab again. But most of the time you'll find it right here. Anything you want to find should be over here.
Okay. And then another question.
Mhm.
So if I wanted to change the frequency for the PWM,
Yeah.
I just do that in hard code, right? Like I kind of just have to set like a prescaler and then kind of determine.
Frequency, like it's the timer itself is set, if I remember correctly, frequency
Yes.
wise. It's just talking about
Yes.
the duty cycle.
Yeah. Oh no, the frequency of the actual
Mhm.
PWM
I
wave
think
or
um uh,
would I have to set up like a counter for it or something or something?
uh I think the PWM symbol itself is already set because there's a clock in there built in for it. Yeah, it's set for 490 hertz.
So there's well, I mean,
But yeah,
there's no.
you can modify it with time, so you can use the timers and look on the Arduino website. So Arduino, um, that's not the lane. Yeah, I think you can change it. You gotta do some more research on this one,
Yeah.
but it does say that you can change the the frequency. But you gotta work with time and roosters for that one. Yeah, this is there you go. You can look at this one here.
Okay.
You want me to send it to you? I can send you the
Yeah, please.
from the chat here. There you go. It looks reliable, but yeah, just do some more research on this one. But I guess you can actually change the timer. You just have to change the. I think it's more machine code. This is binary coding, so yeah.
That's good. Okay. Thank you,
Mhm.
man. You have a
No
good weekend.
problem. You too, sir. Have fun. All right, Bethany.
Good job.
Did I do good? Wait, okay, wait. Let me
Huh?
first. Wait a minute. I need to turn off the recording so I don't like.